Hello there! You must be here to talk about fluvial geomorphology here at the Gallatin River. Today I want to talk about boundary shear stress versus critical shear stress, as well as the relationship between stage and discharge. As most of you know, water has mass and it moves downslope. Because of this, it imparts stress on the bed, and this is called the boundary shear stress, and is a function of water density, the force of gravity, depth, and slope angle. Here in the Gallatin watershed, as well as many other mountainous and alpine environments where it snows, discharge is ruled by the annual snowmelt, with peak stream flows occurring in the spring and low flows occurring during the fall and winter. As discharge increases in the spring, generally stage will also increase. This relationship is not quite linear and is not the same across all streams, but this is due to varying channel geometries and the irregularity of channel geometry. An example of this here on the Gallatin River during relatively low flows is this area where there is an absence of vegetation, as well as a visible high water mark on the vegetation on the bank. It can also be noted that today the water is relatively clear, as there is not that much suspended sediment or sediment being transported downstream. If you came back here in the spring, it would be a totally different story. Waters would be much higher and the water would be very turbid as the boundary shear stress has surpassed the critical shear stress. Critical shear stress is the threshold for stream fission and is based on entrainment of particles and velocities, varying velocities of water. This is a function of uniformity of the bed, sediment buoyancy, gravity, and particle diameter. In conclusion, here on the Gallatin River in the springtime, when discharge increases, stage will also increase. This increase in depth will also, in turn, increase boundary shear stress. And if boundary shear stress surpasses critical shear stress, the stream will incise, entrain sediment, and move it down gradient. Thanks for watching.